Everyone, my name is Dhruv. Today I will be demonstrating the task 11.1p, which is our project report. My project is about the smart car tracking and the accident detection system using the ultrasonic sensor and the GPS sensor, and making the use of Raspberry Pi and the Arduino Nano, and showing the communication between them. For example, in this project I am doing that, and the Arduino Nano will take all the readings about the GPS and the ultrasonic sensor, and it will then pass it to the Raspberry Pi using its IP address on the serial port monitor. So here is our code. So here is the code of the Arduino Nano, in which all the libraries are being defined, which is the Arduino.h library, the tiny GPS plus library for the GPS sensor, the Wi-Fi Nina library for the SSID and password that I provided, the wiring private and the pub sub client library. Here are the SSID and password of my hotspot through which it is connected, and the MQTT server. It means that it is in this I have given my Raspberry Pi IP address. From that the data given to the Raspberry Pi is then stored into the MQTT server, so that there is no communication gap between the data and the Arduino and the Raspberry Pi, and all the data is being stored in a particular space. Here are the GPS pins, that is 5 and 6, D5, D6, and the baud rate of the GPS is by default 9600. Here is the ultrasonic sensor pins, the 9, 10, and in this I am using the ultrasonic sensor for the threshold. It means if the distance is less than 15 centimeter, if any object comes in the distance of 15 centimeter, the ultrasonic sensor will detect, and on the safe distance it will show that the object is too close, or any object is being close to the devices, and it will send an proximity alert to the Raspberry Pi. The Raspberry Pi will show on the dashboard that any of the some object is near to the car, and we can get an email. Here the GPS object, we are using the Circom library, that is serial GPS for the GPS RX pin and the TX pin for their latitude and longitude, and there is a Wi-Fi and MQTT clients. The function for connecting to the Wi-Fi means that how the serial port is connected, and the Wi-Fi begin the SSID and password which has been filled upon on the code. Then we are putting the details, that is IP address, and it is simple. Then we are connecting to the MQTT broker for storing the data. The ultrasonic sensor distance function, the void setup of the while serial port monitor starting of the GPS, ultrasonic, and the MQTT system, the trigger and echo pin output, the connecting to the MQTT server, the proximity detection means any threshold happens, the GPS data in the format of latitude and longitude. Here we can see that we are continuously getting the reading of it. If I place any object near to my car like this, it will show that object is being too close, because our threshold is between the 15 centimeter. If I again put something, it now at the 4 centimeter. On my Raspberry Pi dashboard also we can see that if I start it from the starting, Control X, Control C, first of all we can open a dashboard from this URL. We can open it from here also, and we can also copy it and then again running on any of the web browser for seeing the data. First of all I will show it on from this dashboard. It is the proximity. If I put any object, then it shows that object is being too close, it shows the distance, the location of the car. We can also see here at the dashboard that the alert system sent successfully. An email is also being sent, for we can see the email here. If I refresh it, see here the email is being sent that your car has detected an object, the location, the longitude, and the warning that the car has been, an object is very close, and it also shows the distance and the location with the latitude and the longitude. Here is and all of these servers there will be the application, and if I place any object again, here we can see here also that it also shows that any object is being close to our, and it sends an alert to my email. Thank you. This is the dashboard of the Raspberry Pi. Here my GPS sensor, the Neo 6M, is working. The ultrasonic sensor which is detecting the location, the Raspberry Pi. If I see the current location, if I put any object, it will give an alert, and the GPS is giving the current location. Here is our current location, which is of latitude and longitude, distance 14 centimeter. The alert is true because I have just put an head in between and the current location at India. Here is the alert. Here is the working of my smart car accident and detection system and always on the tracking. Here the GPS location is being tracking the accurate location of the car using the Neo 6H. If any crashes happen, the dashboard also displays it in the terminal. Here is the working of the Raspberry Pi dashboard. Here are the 3 links provided by the dashboard. If I click any of the link and using any URL, and it will open by the inside Chromium of the Raspberry Pi. We can see that here an interface will be open. Here is the interface which will show the car location and the proximity monitor, the latitude, longitude and the distance proximity alert. Here the MQTT is also being used.